Oh, hey there, guys. Cordias here, and this is a video for slope-intercept form. All right, so a couple things we need to know about slope-intercept form is the biggest thing is that slope-intercept form is one way to graph linear functions. Okay, linear functions, that's an important term there, and we've talked about it in the past, but linear functions are lines. Okay, when we graph them, they make a line. Okay, and sorry I didn't say it before. If you've not watched the video for just slope and how to find slope, go watch that first because you need to know that. Okay, very, very important for this video. So slope-intercept form is a way to graph linear functions. So this is going to show us how to take an equation and graph it into a line, okay, on a coordinate plane. So right here would be an example of a linear equation. Okay, I can tell you just by looking at this, because from experience in math and knowing slope-intercept form and knowing different types of functions, this equation right here is going to make a straight line. Okay, and I know you guys have seen equations that look something like this before. Okay, this is going to make a straight line. Now, in the past, when we've looked at equations like this, when people have looked at equations, they always make input-output tables. So they say, okay, so I got an x and a y. Here's my input-output table. So let me plug in the values 0, 1, 2, 3. That was ugly, huh? Okay, and then they plug in 0 to the equation. If I plug in 0, that cancels that out. I add 1, so then I get 1. Okay, plug in 1. 1/2 times 1 is 1 plus 1, that's 1.5. Plug in 2. 1/2 times 2 is 1 plus 1 is 2. Okay, I don't like this method, as you can see by my voice. It's just, to me, this takes a long time. This is kind of tedious. Okay, and I've got more things to do. Okay, this is going to give me 2.5. Now, so then we would plot those points onto our graph. Okay, so I've got 0, 1. I'm just going to skip ahead to my perfect points because I like those more, 2, 2. And then I'm going to cheat real quick, and I'm going to go up to 4 just because I know it's going to be right here. And then here would be the line of that graph. Okay, now, what we're going to do is we're going to learn how to shortcut this so we don't have to ever do an input-output table. Okay, and if you notice, this was supposed to go through 1/2. If I made a straight line, it's supposed to go through 2.5 right here as well. Okay, to match my table. Now, if we look at this, okay, I'm going to show you guys what each piece of this formula means. Okay, and then we can talk about that. So that equation was in slope-intercept form. That's why it was so easy. That's why it's actually really, really easy to graph. Okay, so slope-intercept form is known as y equals mx plus b. Okay, the b is always a piece that does not have the x attached to it. Okay, so the b is what's called the y-intercept. The m is what's your slope. So if we're looking at the last equation that I just graphed, I had 1/2 x, and I believe it was plus 1, right? Yeah, plus 1. So what this information tells me based on this, and I'm going to go into what y-intercept is right now, is that the slope of this line, because the slope is always a number that's attached to the x, so my slope is 1/2. And if you watch the slope video, you should know what that means on a graph, how to find slope. That's just rise over run. Okay, so my slope is 1/2. So that means this line is going to rise up 1 and go over 2. Rise up 1, go over 2. Okay, we'll go back to the last graph and see if it did that. Okay, the y-intercept is where the graph, where this line crosses the y-axis. So that's why it says intercept. It means when it crosses something, when they intercept, when they cross. So wherever that graph crosses the y-axis is this number. Okay, so this one happens to be at 1. So that means this line has a slope, a rise of 1, a run of 2, so slope of 1/2, and it crosses the y-axis where y is 1. So let's go back and look at that. So here's my plus 1. Here's my y-intercept right here. This line crosses the y-axis at 1. So there's my y-intercept. And now what I would do from here is I would use my slope, 1 over 2, because again, rise over run. I would start from my y-intercept, and I would rise up 1 and run 2. And that would be my next point. Rise up 1 and run 2. That would be my next point. Okay. I could also go the opposite direction because I know positive slope is going to go in this direction from left to right. It's going to go up from left to right. I know if I go -1 and -2, this would make a positive slope. And let's look at why. If I go down 1, because -1 would be my rise, that's going down 1. -2 is my run, so negative is when we go left. 1, 2. It still follows along my path. Same thing as going up 1 over 2. Okay? Down 1 over 2. So this is where obviously my line was a little crooked because it should have gone through here. Okay? So, y-intercept, where it crosses the y-axis, slope, rise over run. Okay? And then the y and the x, you guys, in slope-intercept form, they're always just going to be y and x. But if we look at our input-output table, weren't these all points that were on the graph? This is how we graphed it initially. These are all points that are on the graph. So what these x and y represent in slope-intercept form, they represent just any point that is on this particular line. Okay, they represent any point that is on this line. So we can always graph from an input-output table, plug in points, plug in just any x value and figure out what the y value is, and that would give us our points. Okay, and we'll talk about that in a little bit. So first, let's just look on graphing a different equation. So I have y equals -3x minus 1. So again, first I want to look at what's my slope. What do these two numbers mean? What does -3 and which one's -1? So which one's my slope? Okay, so m represents slope. So my slope here is -3. Okay, now that's a whole number though, so that doesn't help me very much. Okay, if I have a whole number, that doesn't give me a rise over run. I can't just go -3. That doesn't work. So what we do is we make it into a fraction, and so any whole number as a fraction has a 1 in the denominator. So my slope is -3 over 1. And then my y-intercept is -1. We just keep the sign that's in front. So if it's -1, that means my y-intercept is -1. So it's always good when we're graphing lines, linear equations, is that we just start with our y-intercept if we can. So I'm going to start at -1. So here's -1. There's a point that is on my graph. Okay. Now from here is where I use my slope. And again, slope is my rise over my run. So I'm going to start from my point, my y-intercept, and I'm going to follow along by rise over run. So if my rise is -3, not +3, -3 would take me down instead of up. 1, 2, 3. But then my run is +1. So I just put it over 1. I didn't put it over -1. I put it over 1. So my run is +1, which takes me to the right. So that's 3, down 3 over 1. I can go down 3 again over 1. Okay? Now, so this is going to give me a negative slope. If I wanted to go this direction as well, if I wanted to keep it going in this direction, I could go up 3 from here. So 1, 2, 3. But if I go over to the right, again, doesn't that give me a positive slope? So I need to go over to the left instead. Up 3 over 1. Now, if I'm going in a positive direction, I've got to go negative on my second one to create a negative slope. And there's my attempt, my poor attempt at making a straight line. Okay? And that would be my graph for this linear equation. Now, this goes on forever each direction. I can keep going, okay? I can plug in infinite points to the left, infinite points, keep going, and it would never go. So that's why it's important to put the arrows on after the end to show that it keeps going. And that's it, guys. That's all we have to do. Okay, let's look at another one. We've got a few examples for you. If you guys want to try this one on your own, try it on your own first, and then so you can pause the video and then see what I do. So first I got to figure out what my slope is, and then I have to figure out what my y-intercept is. Okay, so the y-intercept on this one is +3. So that's where I'm going to start this graph at. Let's switch to red. I don't know why I just want to switch to red. Yeah, pops more. Nice, better color. Okay. So there's my y-intercept. I'm starting at +3. Now my slope, oh, this is kind of nice. My slope is 2/3. So what that's saying is if 2/3 is my slope, here's my rise, here's my run. So, and it's a positive slope, so I should end up from left to right be going up in some kind of way. So if I go down, I know I did something wrong. So my rise is 2. I'm going to go up 2, and then my run is 3. So I went up 2 over 1, 2. 1, 2, 3. Up 2 over 3. There's my next point on my graph. Up 2 over 3. 1, 2, 3. There's the next point. And again, if I wanted to go keep finding points on this side of the line as well, instead of just going this direction, I could go down 2. But if I go down 2, we got to think about which direction I should go to continue this line. And it looks like I need to go left to keep my pattern going. 1, 2, 3. Down 2. 1, 2, 3. Okay, and then I would try to connect these in a straight line, as straight line as possible. That was way better than the last one. And that would give me my line of this particular function. And the equation in the line, this is the line, y equals 2/3 x. Plus 3. Now, these points right here, you guys, so let's take a look at this one point right here. And I'll show you what I meant by the y and the x. This point is the point ordered pair of 3, 5. So because this point is on this line, that means if I plug in 3, 5 from my x and y back into the equation, it would make the equation true. Okay, so I just want to show you what I mean by that. If I plug in 5 equals 2/3 x, and my x is 3, so I plugged in x, the 3 from this point, in for x, and I plugged in the 5 from here, from this point, in for my y, and I add 3. If I actually multiply all this out and I solve it, I should get the same answer. Okay, so if I multiply my fractions real quick, these cross reduce, these cancel, I just get 2 plus 3, which is 5. So 5 does equal 5, that's true. So that means, yes, this point is definitely on this particular graph. So if I made an input-output table, I would have gotten 3, 5, okay, by plugging things in. Okay, all right. Let's take a look at just one more. I just want to show you guys different examples just to make sure we've seen them all. Okay, again, try it on your own on this one for sure, and then check your work afterwards. So pause the video. So I need to figure out what my slope is, and I need to figure out what my y-intercept is. Okay, so my slope on this one, it's given to me -5 over 2. Okay, my y-intercept is -3. So we always start from our y-intercept, find -3 on the y-axis. There's my first point. Now I use my slope from there. So it's -5 over 2. Okay, so this just says -5 over 2. It does not tell you which piece is negative. Is my rise negative? Is my run negative? Okay, so that's why it's important for us to understand, because the slope is just negative, it's got to be going down from left to right. Okay, so we can really dictate, we can choose which one's going to be negative. Is my rise going to be negative, or is my run going to be negative? One of them is negative and one of them is positive, because a negative divided by a positive equals a negative number. Okay, so when I have just a whole slope is negative, I just personally like to just make my rise negative all the time. So when I have -5 over 2, I just like to look at it as -5 and then over 2. This is the same thing as this, okay? Even though the negative sign is way in front of all of this, okay, it's the same thing as having the negative on the top, because a -5 divided by 2 is just -5/2, okay? So with the negative slope, instead of just going up and over, I'm just going to go down and over, okay? So I can go down 5, 1, 2, 3, 4. Oh, I need to add another one, 5, and then over 2, 1, 2. And my point would be right here. Okay. Obviously, I ran out of room here, so I don't want to keep going. And I want you guys to always graph at least 2 points. Okay, at least 2 extra points besides your y-intercept. Okay, so now if I chose to go up 5 instead of going down 1, 2, 3, 4, 5. If I go to the right, I'm not going to have a straight line. Right? I'm going to have this weird sideways V-looking thing, like Pac-Man almost. Okay, so if I go up 5, 1, 2, 3, 4, 5. I need to go left 2, 1, 2. Because I went +5, that means I would need to go -2 to make this still be negative. Okay? And there's my equation. There's my straight line. All right? Okay. Final question that you guys might see is, you might be asked, is this point on this line? So you might just be given an equation. You don't even have to graph anything. You're given an equation and you're given a point. And I'm asking you, is this point on this line? So there's 2 ways you can go about figuring this out. You could graph this if you want. Now this one doesn't look like it's very much fun to graph because it's got a really big y-intercept. I mean, I could, and I don't even need to show like the top. I could just go really far down, just call this my x-axis. Looks like a T-chart, my y-axis, and then count down to 17. Okay, I could do that, but it's going to be not a fun graph to make. Okay, or what I could do is I could just plug in these values into the equation and check to see if it's on the line. If it works out, it's on the line. If it doesn't, it's not. So this is not one of my solutions. This is not one of the equations. Okay, so if I were to plug this in, my y, -2, I would substitute this in for y. So I have -2 equals 3 times whatever my x is. Well, x is 5. And then minus 17. And now I'm just going to work this out and see, does this work? And then that'll tell me yes or no. So 3 times 5 is 15, minus 17, that's -2. And look, I had -2 on the left side, -2 equals -2. It works, so yes, this point is on the line. Okay, so that's slope-intercept form, guys. So remember, slope is rise over run. The number attached to the x is always the slope. The number that's not attached to the x is always your y-intercept, which is where the line crosses the y-axis. Good luck, and if you have any questions, please don't hesitate to ask.